All right, section 4, walkthrough for us. Here we go. So what we start off with here is we've got a 13-gram bullet. Well, that's not going to work in grams, so we got to move that over 3. So the mass here is going to be 0.013 kilograms. All right, 1.5 kilogram block suspended from the ceiling with 2 strings. The bullet becomes embedded in the block, which causes it to raise that much. All right, because it's raising, that's going to be our delta Y. All right, GPE. So if it wants us to calculate GPE, that's going to be the mass of both of them times the gravity times our delta Y. GPE here is going to be 0.013 plus 1.5, that's kgs, 9.8, that's meters per second squared, and then our height is 1.25 meters. All right, we plug that into the calculator. 513 times 9.8 times 1.25. All right, we end up getting 18.53 joules. All right. Determine the kinetic energy of the block and bullet just after the impact. Well, in order for it to reach that height of 1.25, it needed to have enough energy to get there. That energy came from the kinetic energy. So when we say that the GPE is 18.53, well, that all came from our kinetic energy, meaning that that thing was moving initially just after impact, and it actually pushed it up to that height. All right. Calculate the velocity of the bullet and the block. Okay, so we got both of these here, and the velocity of both of these here. Reason we can't use momentum is because we haven't been able to calculate that. We just found out our kinetic energy, which is helpful for us. 18.53 equals 1/2. That's going to be 1.513. That's the bullet and block there. And then times v squared. Okay. Half of 1.513, it's 0.7565. All right, so then we go 18.54 divided by that. All right, so v squared equals 24.51, square root that. All right, when we square root that, we find our velocity is going to be 4.95 meters per second. All right, calculate the momentum of the bullet and block just after impact. All right, so in order for the momentum of both, that's going to equal the mass of both and the velocity of both. All right, we found, or know the mass is 1.513. Again, that's kgs. And we know the velocity from right up above here is going to be 4.95 meters per second. All right, so when we multiply those two together, times 1.513, again, that 1.153 is just the bullet and the block together. Oh, not joules. Kilogram meter per second. All right, so that's our momentum there. Determine the momentum of the bullet prior to the impact. Well, prior to the impact, the bullet is the only one that has momentum because it hits the block that's suspended. So if we talk about the block having 0 kilogram meters per second, because it's not moving, then that means that the momentum of both, which is 7.49 kilogram meter per second, had to come from just the bullet. This one is okay to be the same, because remember, momentum before, momentum after are going to be the same for us there all the time. All right. Determine the velocity. Well, if we want the velocity of just the bullet, we don't know kinetic energy here, right? All we have is momentum. So if we know the mass of the bullet and the velocity of the bullet is what we can find. So we know it's 7.49 equals 0.013 v divided by 0.013. Our velocity here divided by 0.013 velocity here is going to be 576.2 meters per second. All right. Okay, second one. All right, so mass here, that doesn't work. 0.008 kgs on that one. Chunk of wood is 20, perfect, suspended from the ceiling. Oh, we got a velocity now of that, and that's going to be our bullet. All right, how high up will the bullet and block move after the bullet is embedded? All right, momentum. All right, so again, if we're just looking for the bullet here, we need the mass of the bullet and the velocity of the bullet. Okay, so our mass is 0.008. That's again kgs. Our velocity is 442 meters per second. That's a pretty quick bullet. All right, so 0.008 times 442. We end up seeing our momentum here is 3.54 kilogram meter per second. All right. Calculate the momentum of the bullet and block just after it. Well, because that's a stationary chunk of wood, the block here, again, is going to have a momentum of 0 kilogram meter per second because it's stationary. So that means then the bullet which is equal to 3.54 kilogram meter per second, with the block being 0, has to be all of the momentum that gets transferred to both of those. So what we see there is momentum's the same again, which is perfect. All right. Calculate the velocity of the bullet and block just after impact. All right. Well, we don't have kinetic energy. All we have is momentum. So that's the only way that we can solve for our velocity. So if we know the momentum of both, then what we can do is use the mass of both and find that velocity of both. So 3.54 equals the mass of both, so that's going to be 20.008. That's both. So that's the 20 kilograms and the 0.8 kilograms. All right, times our V, so that's both. That's kgs. Okay, so divided by 20.08, divided by 20.08, we find that our velocity here, this is going pretty slow, 0.176 meters per second. All right. Determine the kinetic energy now. All right, kinetic energy, pretty good here. So Ke for both of these is going to be 1/2 the mass of both times the velocity of both squared. 1/2 the 20.008 again. That's again the kgs for both times the velocity of 0.176, that quantity squared. 0.5 times 0.17 times 20.08. All right, so our kinetic energy here, Ke equals 0.310, and that's going to be joules. All right, so all of that, the bullet and the block now are moving. All right, because they're moving and because they're attached to the ceiling with two pieces of rope or wire or whatever they're attached with, all right, this thing's going to curve upwards on that arc path, right? So all of that kinetic energy, all 0.310 joules of it, is going to convert directly into GPE, right? Because we're going to trade speed for height. And this thing is going to now start to climb up in the air, at least a little ways it looks like. All right. Determine the height at the apex. Height, that's my delta y. So if I know GPE, and again, it's still both, so mass of both, times the g times the delta y. 0.31, 20.008, again, that's kilograms, and that's both. 9.8, that's still meters per second squared. Nope, that's still joules, and delta y. So we'll divide both sides by 20.008, let me actually do that. 20.008 times 9.8. All right, make that better. All right, this is going to be 196.08. All right, so 0.31 divided by that. We end up seeing our delta Y here is 0.0016 meters. What is that, like? That's like 1.6 millimeters, so not very far.